All right, we are at chapter 35. This is the first section, so we're going to share uh, share the screen, and we're going to talk about image formation. And they show a cell phone with a magnifying glass, and I've got a magnifying glass here, and this one's kind of dirty, but it gets the job done. Um, we'll discuss lenses in a little bit in sections to follow, but first we're going to start with just mirrors. Now we've done an experiment with mirrors, so we're just going to discuss it briefly. If you look here, the image point I, the image, is located behind the mirror at a distance q from the mirror. The image is virtual. In other words, the rays emanating don't really go through the image. That makes it virtual as opposed to a real image. Now you can see here that the reflective surfaces on the front mirror, that's really reverse of most mirrors, but they're just discussing here for demonstration. Most of the time you get the backside has the reflecting surface, so you actually get two reflections. You get one off the face of the glass and you get one off the reflecting surface. And I think we were able to see that on the experiment videos. And you can see that P and Q are equal. Because the triangle PQR and P prime QR are congruent, the absolute value of P is equal to the absolute value of Q, and H is equal to H prime. In other words, they're equal, so that the magnification is the M is the image height over the object height, which is H prime over H. And we'll see that that's true of mirrors. It's not true of concave mirrors or convex mirrors. There may be points where the magnification is 1, but those are at special places. Okay, and now flat mirrors and apparent left-right reversal. The thumb is on the left side of both real hands and on the left side of the image. That the thumb is not on the right side of the image indicates that there is no left to right reversal. Left to right reversal is a perception. If I hold my right hand up to the mirror, what is on my right is still to the right. If I hold up my left hand, what is on my left is still to the left. Now, my perception tells me that the fellow I'm looking at in the mirror, when I hold up my right hand, it looks like he's holding up his left hand. But what is on my right is still on my right. So it's a matter of perception. There's no real reversal. If there were reversal, the image should be upside down also, besides being left to right. So it's a matter of perception. It's a matter of our perceiving that the person that we're looking at appears to be holding his left hand when we hold up our right hand. So there is no image reversal. What stays on one side is always on the same side. Okay. You're standing approximately 2 meters away from a mirror. The mirror has water spots on its surface. True or false? It is possible for you to see the water spots and your image both in focus at the same time. Now that's false. You can do a little experiment right in front of the computer as you're watching this. I'm holding my finger up and I see my little green camera light. So if I look at the camera light, and it's not even 2 meters, it's just maybe 50 centimeters or less. If I look at the little green camera light, if I focus on it, I've got 2 fingers. I see 2 fingers here. If I focus on my finger, I see 2 camera lights in the back. The effect is more pronounced if you look at things at a distance. If I hold my finger up at the seam where the ceiling hits the wall, if I look at that seam, I see 2 fingers. If I look at my finger, I see two images of the seam. So the answer here is false. You can't look at both of them. It comes from our the stereo vision. All right, and there we'll stop and we'll go on concave mirrors.